So this question is from 2020 June CSIR-NET Mathematical Science. So this series is given where X belongs to this real space R. So to find where the series will converge. So here are four options it's given. So if we consider, let suppose that u of n x is written as minus 1 to the power n sine of nx by n to the power log e to the power n. If we consider this un of x, then if I write it in mod of un, so it will be minus 1 to the power n sine nx n to the power log base en, right? So if we write it, so it will be less than n to the power log en, which will be less than 1 by n to the power n. So if we put the Cauchy root test, so we will see that when we will take this summation from n equal to 1 to infinity, this 1 by n to the power n will always be less than infinity. So this implies that u of nx is less than infinity. Similarly, so this summation n equal to 1 to infinity minus 1 to the power n sine of nx by n to the power log of en, it converges, right? It will converge, and it will converge uniformly for all r belongs to this, x belongs to this r. For this condition, x belongs to this real space R. So in this case, our correct option will be 4, uniformly for all x belongs to R. So the question 25, here we have this an is given a sequence of real numbers, and we have to find which of the following statements is true. So let us check with option 1. This option 1 is stating that summation of n is greater than or equal to 1 minus of 1 to the power n an by 1 plus an mod an. Whether it converges or not, we have to see, we have to check it. So if we consider suppose that limit n tends to infinity, a of n is equal to infinity, then what will be the, it will, so if we put this limit n tends to infinity, so we put the function this minus 1 to the power n an plus 1 plus mod an. Okay, so limits n tends to infinity, so it will be limit n tends to infinity 1. Okay, if we put it over this in this form, an divided by n both sides, so 1 divided by 1 by mod an plus 1, right? And which is equal to 1, and it doesn't tends to 0, so we cannot say that it will converge, so rather it will diverge. Okay, so this particular sequence, you can say that, so it diverges, right? So in our case, the option 1 is not converging, hence it is not true. Okay, now let's check with the option 2. So we have since stated that in the option 2 that we have been a subsequence say of nk, where k is equal to greater than 1, greater than equal to 1, such that we have to find that this subsequence converges in the same manner. It's written in the same form. So if we consider if an is equal to n square, right? So then for any subsequence of this a n k, where k is greater than equal to 1, so this is the subsequence of which sequence? This a n, where k is greater than equal to 1, right? So then limit n tends to infinity, a of n k is equal to infinity. Then what will the limit if we do this? So limit n tends to infinity, a of n k divided by 1 plus mod a n k, right? So this is equal to 1, right, which not tends to 0. Similarly, this particular sequence, this summation of n is this is actually k. So the k is equal to greater than 1, a of nk by 1 plus mod a nk. It also diverges. Okay, it is not converging, it is diverging. So it is not true. Let's check with option 3 then. So there is a number b such that this particular sequence converges. So I have to find that. So option number 3. So there is a number b such that this converges. So let's check with whether it is converging or not. So this is option 3. So if we consider this a n is equal to minus 1 to the power n, then we can write the summation of n greater than equal to 1. So this is our sequence given, b minus a n by 1 plus mod of a n multiplied by minus to the power n, right? So a n is equal to minus to the power n minus 1 to the power n, so it can be written as n is equal to greater than equal to 1 b minus of minus 1 to the power n, so it will be 1 plus 1 a n mod of a n and this minus of 1 to the power n. So we can write it, simplify after simplifying that n equal to greater than equal to 1, so it will be minus of 1 to the power n by 2 whole of this minus 1 to the power n. So here you can find there is no such number b such that this particular sequence, okay, this sequence converges. Okay, so it is also diverging, this doesn't converge, or we can write it. So in our case, both the options are, three options are wrong. It's not true. So the fourth option will be correct, that there is a number b and a subsequence a of k such that this particular sequence converges. So this will be our correct option, option